Okay, so in this video we're going to look at the symmetries of a two-dimensional shape, and we've got four examples here. Equilateral triangle, so all sides are equal. We've got a square, four sides equal. We've got the hexagon, six sides all equal. And here we've got a rectangle with only two sides equal. So that's that. And that what we're looking for is some sort of relationship between the number of symmetries between the number of sides. So first of all, let's have a look at the equilateral triangle. So the equilateral triangle, three equal sides. So we're looking for rotations and reflections. So let's put here for the triangle. And we've got a table here for rotations and reflections. So I'm just going to put it like that for now so we can see what's going on. So rotations first, let's have a look at that. So if we put the centre of the triangle here, how many times can we rotate this triangle? So if we put a little line down here, a little line down here, and another line here. So our first rotation is going to get this side onto this side. So that will be this rotation here. So that's our first rotation. And then what we can do is to get this side onto this side, we can go around twice. So we'll go here to here to here. So then we'll go round this amount. And then to get back to where we originally started, we can rotate all the way around and do one full turn. So the rotations here we've got are three. Now, okay, so 360 degrees in a circle, which is 2 pi, and each rotation for three, obviously if they're equal, is going to be 2 pi over 3. So these are going to be 2 pi over 3. Okay, so now what we want is reflections. So I've drawn these lines here, and what we're looking for is if we turn it over in any sort of perspective that we like, to get it back to looking like the same shape. So we can we can reflect through this line here. So we're reflect it through there. We can reflect it through this line here. So we can reflect it there. And then we can also reflect it through this one. So we see here the equilateral triangle has got 3 reflections. Okay, now what about the square? So this time we've got 4 sides. So if we draw an axis here to try and find the rotations, we could turn it around once to get this side onto here, then all the others will stay the same. We could turn it around twice, so this side will end up here. 3 times this side will end up here, and 4th it will end up back where it was, i.e. the identity symmetry, i.e. where nothing will happen, and that's always on a rotation. So for the square, we've got 4 rotations, and again, as we're rotating through 2 pi or 360 degrees, and we've got 4, each rotation is 2 pi over 4. Now that makes sense because each corner of these are right angles, which is going to be 90 degrees. And to get each one to each one, that's 90 degrees is pi over 2, so therefore we've got 2 pi over 4 for each rotation. Okay, now reflections. So we can use these vertices here, so we can reflect it this way, so i.e. through this plane, and then we can also reflect it this way through this plane. So that's going to give us 2. But there is also 2 more which we can find. If we draw a line through here, we can then also rotate through this line here and also this line here. So that would then give us 4 reflections. Okay, now what about the hexagon? A lot more tricky now, we've got 6 sides. So let's draw lines through here. So we find the centre of the hexagon. So now our rotations now, we're going to go through each one of these angles. So each one, to get this side to here, we just got to turn it to here. So we're going to turn through this amount, so that's 1 rotation. And then starting from here to end up to here, so the shape will still appear the same after it's been rotated. So it's very important when we're doing rotation. So we go from here to here to here. We're then looking at this rotation. And then if we want it to flip around 3 sides, so this side goes to this side, then this side, then this side, then we're going to rotate along that plane. And now for this side to rotate all the way around to get to here, we are looking at this rotation. And then this one here, if we go all the way around to this rotation, we're going to go around again, it's going to end up here. And then finally the last one, the identity rotation, we rotate it all the way around so we end up back where we started. That will be our final one. So we've got 1, 2, 3, 4, 5 and the identity 6. So hexagon has 6 rotations and the angle through each one will be 2 pi over 6, i.e. pi over 3. So same for this one, would be pi over 2. So but we can see that from what's going on. But if I leave it like this, you'll see there's a way of finding out what all of these ones will be without even trying to work it out and drawing the diagrams. So now what about reflections? So we can reflect it through this plane here, that's fine. We can reflect it through this one, that will bring it back to where it was. We can also reflect through this one, that will bring it back to where it was. That gives us 3, but then we can also get 3 more. So if we go through this one here, it's going through the centre, go through this one here, it's another one, and this one. So that's then going to give us 3 more. So we're going to go through this one, and this one. So that's then going to give us 6 reflections. So you can see here now, the pattern is, if we call these sides, so this is triangle, that's got 3 sides, and bearing in mind these are equal. So equal sides, square's got 4 equal sides, hexagon 6 equal sides. The rotations and the reflections is the same amount as the number of sides. So we basically got, so if we put n-gon, so call this an n-agon. So hexagon for 6, obviously square's got its own name. We've got pentagon for 5, that's 5-agon. Nonagon in 9 sides, and so on. So rotations are n. The reflections are also n. So total reflections plus rotations equals 2n. And the rotations are through 2 pi over n. So we call that 2 pi over n. So that's what we can see for regular polygons. Now what about a rectangle? So slight problem here. These are not equal sides. So these sides are equal and these sides aren't equal. So let's write the rectangle here up here on its own. So it's got 2 sides that are equal. Now let's have a look at the rotations. Now if I rotate it through this axis, sorry, that's reflected, so if I rotate it through this angle here, the shape will not come back to its original form. The shape will be sticking up here somehow, which is not a symmetry. What we need to do is rotate it through 180 degrees. So the first rotation we've got is this one here, 180 degrees. And then to get it back, we rotate it through a full 360 degrees. So this has got 2 rotations. Okay, now what about reflections? So with all these, we draw the lines through here. Now if reflect it through there, that's fine, that works. And if you reflect it through this line, that also works. So that's our 2 reflections there. But what about if we go across? So if we do it across this axis, this is going to end up somewhere down here, which is not going to return to its former position. And same for this one. So these ones here through the endpoints don't work. So we say a rectangle has got 2 rotations and 2 reflections. So what we do here is we count up the amount of equal sides, and it's the least amount of equal sides, and that will give you the 2 times of that rotations and 2 of that reflection. So here we've got 2 equal sides twice. So therefore our rotations are going to be, so if you call this the n, so we've got n rotations and n reflections. And these again will be through 2 pi over n. So for here, for 2 pi over 2, each rotation is through pi. Now if, for example, we had 6 sides, of which 4 are equal and 2 are not equal to these, but 2 equal in a different way, then the same would apply as the rectangle. We'd use the 2 as our n. So it would give us 2 rotations and 2 reflections. Okay, so that's our 2-dimensional properties for symmetry.